Okay, 11.3a notes. Identifying geometric sequences and then writing general rules for them geometric sequence. Now, geometric sequence tends to be exponential. And again, a sequence, a list of numbers that follows a specific pattern. If it is geometric, the pattern that it's going to follow is that it is multiplying by the same number every time. Now, when you start looking at division, you can always think of division as multiplying as well. It's just if you were dividing by 2, you can think of it as multiplying by 1/2. Now, we call it a general rule, and it's also going to be called an explicit rule. And for geometric, once you notice that it's multiplying or dividing to get to that next term, what we're going to use is a sub n is equal to a1 times our common ratio to the n minus 1. So again, a1 is the first term of the sequence. And then r is going to be our common ratio, or what we're multiplying by to get to that next term. So, just determining if something is geometric or not. Looking at that, how are we getting to that next term? And if it's geometric, again, we're multiplying to get to that next term. So to get from 4 to negative 8, I'm going to multiply by negative 2. So let's check. Negative 8 times negative 2, that works as well. 16 times negative 2 is negative 32. Since it's following that pattern of multiplying, yes, it is geometric. Okay, and let's go ahead and let's write the explicit rule. And again, a sub n is equal to a sub 1 times the ratio to the n minus 1. So in this case, a sub n is equal to the first term, which is 4, times the ratio, which is that negative 2, to the n minus 1. Moving on to b. To get from 3 to 9, I would have to multiply by 3. To get from 9 to negative 27, I would have to multiply by negative 3. Now, 3 and negative 3 are complete opposites, meaning we are not multiplying by the same common ratio, where we don't have a common ratio is what I should say, meaning it is not geometric. Not geometric, we can't use our a sub n is equal to a1 times our common ratio to the n minus 1. Again, because there is no common ratio in this sequence. So, write a rule for the nth term of the sequence. Now, it's a little bit harder. I'm trying to go from 5 to 2. I can't think of anything to multiply by. So, in cases like this, okay, and you can also tell that it's not arithmetic, so it's subtract 3, that 0.8 throws it off right there. So, if you're not sure, let's check. What we're going to do is we're going to take one term and we're going to go to the previous one. And we're going to say 2 divided by 5. 2 divided by 5, which is 0.4. And then, again, just checking another one, 0.8 to 2. So 0.8 divided by 2, guess what? It's 0.4. Or 2/5. Okay. Since those are the same, which you would get the same thing if you did 0.32 divided by 0.8, that would be 0.4. That is how you are finding your common ratio on harder ones like this, where it's tough to see. It's not just a whole number you're multiplying by or dividing by. It's going to be some type of fraction. So in this case, we got a ratio of 2/5, or you could say 0.4. Either way works. Okay. And then the nice part about geometric, guess what? We just need a sub 1, which is always just that first term, which is 5 in this case. So our explicit rule, or our general rule, a sub n is equal to a1, which is 5, times 2/5 to the n minus 1. or you could write it as a sub n is equal to 5 times 0.4 to the n minus 1. Either way works. Now, finding that eighth term, so we're finding a sub 8, again, which is just referring to the eighth term of the sequence. All we're going to do is replace n with 8. So that's saying 5 times 0.4 to the 7th. Once you plug that into your calculator, you're just going to get 0.008192. Okay, so again, finding the rule is a little bit different with geometric sequences compared to arithmetic. It's because they have different general rules. When it comes to finding a specific term, there's no difference there except that you're obviously having a different general rule for each given sequence. But again, finding the eighth term, you're just plugging 8 into n no matter what your general rule is. Alright, so one term of a geometric sequence is a4 is 3. The common ratio is 3. Write a rule for the nth term. So we have a sequence and we're given the fourth term. So a1, a2, a3, a4. I'm given this term and I know that it is 3. Now, we know the common ratio is 3. So the only thing I need to do in order to write the rule, again, if we remember a sub 1 times the common ratio to the n minus 1, all I need to find is a1. So given that we're given a common ratio, to get to that next term, we would multiply by 3. To get back a term, we would divide by 3. 3 divided by 3, which would be 1. 1 divided by 3, which would be 1/3. Divide by 3 again, 1/9. Okay, now, this wasn't too bad at this point just because I was at the fourth term and I need to work back to the first term. But if I was to give you a case where it's the 12th term and you need to go back to the first term, there's a much more efficient way of doing this. Okay, but let's just finish writing the rule again. So a sub n is equal to the first term, which is 1/9, times the common ratio of 3 to the n minus 1. Now, again, if we didn't have a case where we're so close to the first term, this is what we're going to do. We know that the common ratio is 3, but I don't know a1. But if I take 3 and I plug it in, I get a sub n is equal to a1 times 3 to the n minus 1. And then I'm also given a term. So I know a4 is 3. So I'm going to say 3 is equal to a1. And then if it's a3, that means I have my n, or sorry, a4, 4 minus 1. So 3 is equal to a1 times 3 to the third, which would be 3 is equal to 27 a1. So if to solve for a1, divide by 27, divide by 27, 3 over 27 is 1/9. And again, either way is going to get you there, but if we're given a term like a12, the method in blue is going to work much more efficiently. Either way gets you to the overall goal of finding the general rule. Okay, now given two terms. So we have, let's say this is a1. Here's a2, which is -4. a3, a4, a5, a6. And we know that one's -1024. We have all those three missing terms in there. But we do know if I multiply by that common ratio, we'd have to multiply by that common ratio 4 times to get to that -1024. Or you can think, okay, if I'm going from second term to sixth term, 6 minus 2 is 4, so I will have to multiply by 4 times. So we can write an equation here that's going to help us solve for that common ratio. Because if I say -4 times r to the 4th power, since we multiply it 4 times, we know that that's going to equal -1024. That is an equation we can solve. Divide by -4, divide by -4. I know r to the 4th is equal to 256. So and then to undo a 4th, we 4th root. So r is equal to plus or minus 4. Now, we're going to use both of these because either way, we're going to get the rule that follows this sequence. So, either way, a sub n, that ratio is either going to be 4 or that ratio is going to be -4 to the n minus 1. Now, depending on which way we go, so let's say we use the +4, and I work backwards, meaning we're going to divide by 4, so -4 divided by 4, that would give me -1. But if I was to use that common ratio of -4 divided by -4, that's going to give you a +1. So either one works. I am just going to ask you to find one of them. So in this case, if you picked the +4, that first term would be -1. If you pick the -4 as your common ratio, moving backwards one term is going to give you a first term of +1. Either one, both of them are not required. Okay, so again, same idea. We're given a 3 and a 6. So 18 is a 3, -486. I would have to multiply by r, multiply by r, multiply by r 3 times. So again, or just 6 minus 3, we can think 18 times r cubed is equal to -486. Okay, fine, solving for r, divide by 18. We're going to get r cubed is equal to -27. Cube root. We get r is equal to -3. So, at this point, I got a sub n is equal to a1 times -3 to the n minus 1. Working back, so if I just work backwards, a2, a1, that's my goal, is to get there. I know I have a common ratio of that -3, meaning instead of going back a term, I'm going to divide by -3. 18 divided by -3, we're going to get -6. -6 divided by -3, we're going to get +2. Therefore, first term is 2. And since all I need in order to write an explicit rule is my first term and my ratio, plug it in, and there we get that. That's it for 11.2a, geometric sequences. There will be a homework, 11.3a. Make sure to do your homework. Other than that, have a good day.